Yeah, I'll be talking about how to build a game master with Strngs Agents. Um, I'll show you how to use this. Strngs Agents is an SDK that we open sourced at AWS that allows you to build agents in just a few lines of code. And I'll have a few slides before just to make sure that everybody understands what's. I'm going to start with what an agent is. You used most probably you know LLMs, which are large language models that are basically AIs that you can talk to. So you can think of ChatGPT, but there's a lot of others LLMs that have this capacity of conversing with you. Um, Agents are the step after, which is basically LLMs that have access to tools. I like to make the image of the agent is a ChatGPT with hands. So it's an LLM that you can converse with, but it can also do actions for you. And that's the step we were missing if you wanted to have like a Jarvis, for example. So basically, like if you ask something like, I don't know, uh, book a train ticket for me to go to London, then ChatGPT isn't able to do that because it doesn't have access to the your credit card, and it cannot go to the website and they book the train for you. But if you give it the API calls, if you give it all of the informations that it should have access to do the act, to perform the action, then your LLM is basically an agent. So it has agency, it can do things. Um, so tools can be different things. They can be functions running locally. They can be functions running on service. They can be Lambda. They can be it can be also a database, so a knowledge base that your LLM has access to have more knowledge about a certain area. It can also be other types of databases that, for example, you have customer data or something like this, and you want your LM to be able to go through that database, then it could be that too. Could be a lot of different things. Um, and we've talked about MCP, so that's a good thing. I'm going to do a little introduction about what this is, but basically what MCP means is Model Context Protocol. It's a protocol that has been made in place because before MCP, we had agents and we were making tools for those agents. But you had to manage everything um, from the connection between your agent and your tools, the way your tools were returning format queries and responses. You had to make sure that you were managing both your tools and your agents. And there was no standardized way of doing this. MCP is the protocol we needed for standardizing all of this, for standardizing the way agents or LLMs were having access to tools. And what this created was also the possibility of not only creating your own tools, but also other people to create their own tools. And so you can connect your agent to their tools. And if they follow the standard, then you can connect your agent to pretty much any tool, which is cool because then you don't have to manage everything. And from the side of the people serving tools, then it's great because you don't have to care about how people were, making their agents, and you didn't even have to care about making a documentation on how to use your tool because there's a standard. It's like APIs reinvented for agents. REST API. And so there's also another protocol that I will talk about is A2A, agent to agent, which is pretty much the same thing as MCP, but specialized for the communication between agents. So agents to agent communication. So the standard is different because a tool and an agent doesn't work the same way. But basically, if you need to simplify things at its most, then MCP, the EMCP protocol is the communication from agents to tools, and A2A is a protocol that standardizes the way agents communicate with each other and collaborate with each other. Yeah, so that's basically what this slide is saying. And so going on to the demo, I'm going to show you different things. I'm going to show you how with Strands, which is an SDK that we open sourced at AWS, you can easily build multi-agentic workflows with agents communicating with each other through the A2A protocol and agents communicating with tools through the MCP protocol. And I'll show you in a bit how to build this app. So here's the presentation of the Strands SDK. Feel free to contribute also because it's open source and we love to have your contributions and also thoughts and feedbacks and issues that you can return. This is really recent, so we're still building it. Although we use Strands as an SDK to build our own applications internally. So it is already, stress tested at its most because we deal with huge scales at Amazon. So yeah, to install the Strands SDK, it's really simple. Just install Strands Agents, and here's the demo. Let me go to my code. So forgive me because today, for some reason, my auto completion doesn't work, so I'll have to type everything, which hopefully will work for this demo. So first, we're going to create a very simple agent. So from the Strands library, we're going to import the agent class. So to instantiate your agent, just simply call the class agent and call it with, I don't know, hello world. And here you just have to launch your code. And so very simple, basic hello world send to an agent that is by default, if you don't define here any model, by default will send the query to Cloud 4 on Amazon Bedrock. So you have this little thing here, like the print agent.model.config. If you play this, then you'll see which model you're tapping into. This is going very slow. Okay. So here's the model ID, Claude 4. But I will use Haiku. So Strands has been made provider agnostic, which means that you can easily switch between providers. You like by default it goes to Bedrock on Amazon, on AWS. But if you here define a model, you can tap onto any other model provider that you have access to if you have the API key. And also you can also tap onto local models. I'll show you in a second how to do this. Okay, cool. Let me show you how to use, for example, local models. So I have downloaded in the documentation here, you have the different models that you can use. Here, Olama. I'm using Olama to show how you can use a local model for your queries with Strands. So from Strands, import Olama model, and then the only thing you need to do is to instantiate your model, Olama. And then I'm serving my Olama model. Where is it? Here. Olama list. Okay, there it is. So just give the model ID you have. here it's, for me, it's Llama 3.2 latest. And also the host. By default, Llama is hosted here on port 1143. And then you just have to here pass the model here. So now it should use my Llama model that I have locally. Yeah. So the answer, as you can see, is much shorter, but that's because the model also is tinier because it's hosted on my computer locally. So of course. All right. One of the things, so here we just created an agent that still doesn't have access to tools. Right now, it can just answer questions. It answers actually the hello world here that I asked here. But now if you ask questions such as, let me go back to haiku. Let me erase this. If you ask questions such as, what time is it? Normally, what it does is that it's unable to answer your question. It's unable to answer your question because it's a model that has been trained at a certain period of time and then it's hosted somewhere here on the cloud on AWS, but it doesn't have access to the time. And it's what it's telling you. I don't actually have information about the current time. Maybe it's going to give you an advice like check your watch. Sometimes it does this. So this is where an agent comes into hand. It is really handy because it has access to tools such as maybe a function that gets the current time and then give it to the LLM so it can formulate an answer. And we have built-in tools with Strands. You can use built-in tools. Where are they? If you go to tools here, yeah. So you have community built tools, which basically, if you install this library, Strngs Agents tools, then you'll have access to all of those available tools that have been created by the community. And today, if I want to ask the time, then I can get the tool that is called current time. Let's go back to the code and see how we can do this. Actually, it's Strngs tools, yeah, from Strngs tools, import current time. And the only thing you need to do is to pass it here in a list. Oops, sorry. Yeah. And then what happens here is that your agent has access to the current time tool that we just imported here. So now, oh yeah, sorry. So now what's doing is that my agent acknowledges that it has a list of tools and knows that it has a tool called current time. The way it is coded behind the scenes is that the current time function has a docstring that the agent actually reads and understand that this function actually is helpful to get the current time, and then execute that function and get the answer back. So that's how you can use tools. You have other tools that are, you know, like more interesting. Am I going to try this one? Yeah. So for example, here you can import other tools to write files and to execute Python code. So let's try to give those tools to our agent and then ask something a little bit more complex, such as write a function. Oh, write a file. I'm sorry. Write a file. How are we gonna call it? .py that calculates the first n numbers of the Fibonacci sequence and execute it. So let's see how it performs on this task. So first, it knows that it needs to write file. It's asking me the permission to actually write a file locally on the root of my folder. And here you can see the file has been created. And now it's asking me if it can execute the code. So we can see that in the fib file, it has created this function. And now it's executing the code, returning the first n numbers of the Fibonacci sequence. And it's actually telling me what it has been doing, which is really cool. Yeah, so that worked. Awesome. But sometimes you need other tools than the tools that are built in. You need to create your own custom tools. So now we are going to create our own custom tools because we want to create a game master. Let's see how we build custom tools. Just call here. I think it's tool. Yeah, I don't coding like this is a mess because I don't have autocomplete. So interesting. Yeah, it should be like this. So from Strands import tool, and then create your own function. For example, we want to create a function. Sorry. We want to create a function that will allow our game master to roll a dice. And because I'm lazy, I'm going to ask Kiro to write it for me. So write a function that rolls a dice with a number of faces passed as a string because the LLM sends strings back, so it needs to convert it to integers, and then we're going to ask it to manage errors. Okay, function that rolls dice, number of faces. Okay. Okay, cool. Let's accept this. So here we have a function that can roll dices. The only thing that you need to do to convert that function into a tool is to add the decorator tool right in front of it. And then you give this tool to your agent. And now, if I just ask roll a d20, if I'm not mistaken, it should. Oh, yeah. No. Yeah. This live debugging. Okay, so that's cool. So it actually, now that we've wrapped our function into the tool decorator and passed the name of the function, it has a roll dice function. Even though I have not, and this is not best practice, even though I have not put a doc string in my function saying exactly what the function is meant for, my agent actually understood by itself what it's doing. Let me just ask Kira to generate a doc string. String. Is it gonna work? Whoa, Oh, that's cool. Yeah. Okay, that's a very long docstring for a dice roll function, but this will do. Okay, cool. Now we've seen, how long do I have left? Okay. Now we've seen how to create an agent, how to use built-in tools, and also how to create your own custom tools. Now we'll see how to connect your agent to an MCP server where we do have a function that is served. So we'll just move the roll dice function onto an MCP server. Let's create a file called MCP server. And let's move this here. Okay. And let's create an MCP server where we have our dice roll function that runs onto it, fast MCP. What we need to do is first to create the MCP server. So just fast MCP. And we'll put it on port 8080. You can give your server a name, like another, but yeah, here it works as simply as that. And then MCP run and transport HTTP streamable. I'm just going to copy this from the documentation. Okay, so this is just enough to run your MCP server. And we're just going to add the function that I coded here. Okay, that we want to serve right there. And you just need to change this as it's not a tool anymore, it's an MCP tool. Is this enough? Yeah, I think so. So now if I run this here, yeah, of course. Is this good now? Okay, so now on port 8080, my MCP server is running, which means that basically my function roll dice is now available to be used by any agent that has access to this URL. So going back to demo here with our agent, we need to import two things, which is the fact that it's now an MCP client and the streamable HTTP client. So I'll add this line. Oh, wait, let me show you. Okay. Where I give, let's just call it MCP client, the endpoint of my MCP server that is running right here. And now we need to add a with statement where we create our agent. Put everything in here. And inside of this with statement, we need to get the tools from the MCP server. So the first thing you need to do is get it from a method called listtool sync. So it's MCP, MCP tools equal MCP client dot list. Oh, I can't remember how it's written. Let me check in the documentation. Oh yeah, like this. Okay, and the only thing you need to do is to pass this into your tools. I think I'm good. Okay, let's try. Python demo. So now you can see what's happening is that my MCP server here is listening, and it has the function roll dice. And here, when I launch this and I ask my agent to roll a dice, it knows that it has the access to a tool that is on an MCP server. And it's rolling the dice. So it's actually running the function and getting the result of that roll dice, which is, here's the result, but it didn't show me the result. Let me ask again. Ah, 7. Yeah, it just rolled the dice. For some reason, it was not showing anywhere, but yeah. So that's cool. What we've seen so far is that how you can so run a tool on an MCP server, and now we'll see how you can connect two agents together through the A2A protocol. Let me get rid of this, and let's create an agent that will be specialized in character creation, the agent character. Okay. So my AI game master now has access to a dice rolling function, and we're going to give it access to another character, which is specialized in the creation of other characters in the game. So let me just yeah, let's create an agent. I'm just going to copy this here. And then agent equal. Now that my agent is an expert and is going to interact with the AI game master, I need to give it a name and a description because my AI game master will read this to understand if it needs to use the agent character, and it needs to have a full description of what it does. So I'm just going to give it a name, D&D character management. I'm going to give it a description. I mean, the longer your description is, the better, but here it's a demo, so I'm just going to try, oops. I'm just going to try to make it short. You are a character expert. You can create and manage characters. What else? I'm just gonna try this. And let's give it tools to create characters. So usually what you're gonna have is a database of characters, but here we're just gonna make it create files locally. So do I still have? I don't. It's Strands tools, import. What was it? File. Right. And what was the other method? File read. Okay. And let's pass this as tools to my agent. Okay. What else do I need to do? Oh yeah, I need to create the A2A server. So my character agent will run on an A2A server. So we need to create an A2A server. Strands. Let me check in the documentation. Oh, yeah, Strands. Oops. Okay, A2A server, and let's serve this in a certain port. A2A. Oh, let me put this right after because we need the agent. Yes. Let me think. Okay, so we need to then serve. It's as simple as the MCP. When we had the MCP server, here the line was MCP run. And here it's A2A server that serve. And this should work. Okay. Let me serve it. I don't think I'm logged in here. Okay. There. Python agent. Of course. Where is it? Oh yeah. Come on here. Oh, yeah, because I'm not in my environment, but I also need to, sorry for this. I need to be logged in so my credentials are working to call onto Bedrock. And yeah, and I need to activate my virtual environment. And now this should work. Okay, so now I have an A2A server running on port 8081. And my AI game master needs to be aware of this. So we need to give it also, like we did with the MCP server, we need to give it the URL. So A2A provider. And let me copy this. Oops. Here. All right. So what we do here is that you import the A2A client library, and from here you give all of the known agents URLs. So you can have multiple agents running on A2A servers. Just give it all of the different URLs right here, and it will be able to discover them all. And of course, you need to give it the tools. So you can concatenate all of the tools that you have from the MCP tool servers and also the A2A provider that tools. And sorry. And when you create your agent, then it will have access to the tools from your MCP server and the tools from your A2A agent, which is the character agent that is running here. So let's see. Actually, let me put this here. And that's not working. Okay. And let's see if, oh, let me ask you a question where I actually do ask the creation of a character. Create a character called, Gypsy is the name of my dog, called Gypsy, and make up its stats. Oh, cool. So what my agent is saying is basically it's using the dice roll to roll the dice for the different stats of my character, and it's actually creating my character on the fly. But it has not. Oh, it has not used. It has not used the agent character. Let me do a better system prompt. This is where you realize that when you have multi-agentic workflows, you actually need a good system prompt. So I need to tell my AI game master that this is an AI game master. You are an AI game master. You have access to, let me put this in multiple lines. You have access to dice roll function and an agent expert in character creation. Okay. Oops. That's not what I meant. Nah, that's not what I meant. Okay. First, check the tools you have access to and the agents. And the tools and the agents you have access to. Then decide what to use. Yeah. Let's see if now it uses my agent, my character agent. And I want to watch here. Here we should see if it's calling my agent character. Oh, there you go. So what happens is in the A2A protocol is that it's first going to get what we call an agent card, which is basically the description of what the agent is, and it's giving it back to the AI Game Master so it actually knows what to do if it can use this. This is interesting because you can see now that your two agents are collaborating. They're talking to each other. Basically, what it did at first was getting the cards, so it's discovering all of the agents it has access to, and now it's asking my character agent to create my character Gypsy, and it's actually writing a file where it did create my character right there and dropped all of the stats of Gypsy right here and giving back all of the information to my AI Game Master. So my AI Game Master also has a memory during that session of what character just has been built. So, and it should have also had used my dice rolling function, as we can see here, it has called it, to roll dices to create my character. Awesome. So I showed you in just a few lines of codes how you can create agents to talk to each other and agents to talk to MCP tools. Now I'm going to, I think, let's try to show you the actual full demo of this. Let me kill all of my agents running somewhere, so my ports are free. Yeah, so I have a full demo where I actually I even have a UI where I play with sometimes. And here is a little bit more complex. I have three different agents. I have one character agent that has access to a database, an actual database this time, not just a file that it writes to. I have a rule agent that is an agent that is an expert of the rules and has access to a knowledge base, where I dropped all of the rules of the Dungeons and Dragons game. So whenever it needs to ask a question about, the mechanics of the games, my AI Game Master will ask the question to my rule agent. And I also have a dice rolling function running on an MCP server. And here is my game orchestrator, so the AI Game Master. I just need this URL right here. And let's see here, I'm going to start a new game. Let's say Gypsy is, yes, she's a girl. And then I'll just use this to generate a game. And what should happen here is that when you play the generate game, my AI Game Master first discovers all of the agents it has access to and creates the character for me. So Gypsy, that is I think an elf I chose, of cleric. And now this character is automatically dropped into my database. Send this back to the Game Master Orchestrator. So now it has created my character. Oh, too bad this isn't working here, but there should be a nice image. And now I can start playing the game. I have a few pre-written actions that I can do, but I'll choose investigate the glowing shrine and pry for guidance. And so this sends a query to my AI Game Master, which decides, whoa, error messages. Well, live demo, there you go. Where it chooses to roll a dice to see if I actually can investigate, I guess. It hasn't asked the rule agent if it can do stuff, so I guess it depends on if my system prompt is well written. But now it has returned the following of the game, and this is how you can create a multi-agentic workflow with different agents that are experts in different things. Yeah, I don't know if was too long, but this is my demo. If ever you have any questions. Oh, also, sorry, I need to go back to my presentation just to share with you a few things. Um, if you found this cool and you want to test code samples with Strands, then here is the first QR code that you can use to try it on your own. Also, here is a link to the documentation if ever you want to dig deeper into how Strands work. And also, I have a CTA for you. Reinvent is at the end of this year. Every year in December, the first week of December, from December 1st to December 5th. If you use this code, you can redeem the first 100 person who uses this code can have a $150 off of their tickets, which is really cool.